Welcome back, everybody. Mr. Renneker here again today. I'm very excited to introduce to you the Pythagorean theorem. I know we've waited a long time this year to finally get to this topic. So your objective for this first lesson is to use the Pythagorean theorem to solve for side lengths of right triangles. And by the time we're done, hopefully that'll make a lot of sense. Let's get started. First, let's look at our key ideas. So when we talk about a right triangle, of course, there are three sides to that triangle. Those sides have special names. First here, we can see that the legs are the two sides that form the right angle. Now we call those sides A or B, and it'll be important to note early on that A and B can change sides. A isn't always on the left or B on the bottom or anything else. And we could have called this one B and this one A if we had really wanted to, and that's not going to change our work later on. Now, this next one, this is a fun word here. It says the hypotenuse is the side opposite the right angle. It's probably going to take a couple tries for us to start saying hypotenuse correctly. It is important to note, though, that the hypotenuse is always described using the variable c. So the legs A and B can switch around. For the hypotenuse, it cannot. It must be labeled as c. Now, when they say the hypotenuse is the side opposite of the right angle, what we see here is you've got your right angle symbol. What helped me always identify that hypotenuse was imagining that that right angle symbol was like the point on an arrowhead, and that point, it's pointing towards, of course, the hypotenuse itself. That might help you remember as well what they mean by the side opposite of the right angle. Down here it says, in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. That's very confusing, and you might want to pause the video and then go ahead and reread that description a few more times. And all they mean, though, algebraically is simply this. If we take the square of the sum of the squares of the legs are A and B. So if we square A and find the sum of the square of B, so add them together, those two squares will always equal the square of the hypotenuse itself. Now, there are a lot of video proofs and examples we can do to go through why that relationship is true. In this video, we are not going to go through a lot of that discovery. However, if you go into our Google Classroom and if you go into the PDF lesson plan, there are some extra videos that will help show you some of that proof if you're eager to know why a squared plus b squared does in fact equal c squared. So take a look at that on your own if you would like to see that. But we're going to go ahead and get started into our first example. So in example one, we're finding the length specifically of a hypotenuse, which is of course marked C here in our picture. And it is also important to know that the hypotenuse is always the longest side on a right triangle. So if we have measurements of 5 meters and 12 meters, C has to be bigger, or I'm sorry, the biggest number out of the three. So if we were to solve this, for example, and say, oh, C must equal 10, that would be a good time for you to pause and say, wait a minute, that can't be true. The hypotenuse has to be larger than any of the others. Having said that, to go ahead and find our hypotenuse, we're going to start by using Pythagorean's theorem, which is a squared plus b squared equals c squared. From there, ladies and gentlemen, it is pretty straightforward as far as substituting in the values you're given. Again, the legs are A and B. It doesn't matter which one you denote as A or B. I'm just going to go ahead and call this one A and this one B. If you wanted to flip them around, or if you want to try that with me, you'll note that you're going to come up with the same solution either way. So in my situation, A is 5, so we're going to find 5 squared, plus B is 12, so 12 squared, and that should equal C squared. We'll go ahead and simplify what we can. See, 5 squared, that's 25, plus 12 squared, which is 144. It's a good thing we've went over squares recently. Some of these you might have memorized. And we know that'll equal C squared. 25 plus 144 is 169, which equals c squared. And that's great so far. I mean, everything I hope would be pretty straightforward. However, we're not trying to solve for c squared. I just want to know how long side c is, meaning we need to solve this for just c. Well, if we have c squared, how do we go backwards to find out what just c is worth? And again, hopefully due to some of our more recent lessons, it should become pretty obvious to us that in order for us to do the inverse operation of squaring things, we're going to have to go ahead and algebraically square root each side. Well, on the right-hand side, the square root of c squared, well, that's just c. Again, squaring and square rooting, those are inverses. They cancel each other out. On the left-hand side, though, we would have to find the square root of 169. For most intents and purposes, you might not need a calculator here if you've taken some time to memorize square roots. Otherwise, you are going to have to use technology because the square root of 169 is 13, which means that the hypotenuse is 13 meters long. So that's the big connection between our most recent lessons in the Pythagorean theorem is our requirement to use roots and powers here. But let's let you guys work on a couple of your own before we go too much further. All right, for the first two examples that you can try on your own, you're going to find the length of the hypotenuse. Again, they have given you the lengths of both legs. So use a strategy exactly like what we did just a moment ago in our first example. Go ahead and pause the video if you want to try these on your own, and in a few moments your solutions will appear. And here we are for number one. You should have found a hypotenuse, or C, was 17 feet long. And for number two, the hypotenuse was 1/2 inch. If you were successful, great job. If you had any confusion and you can't figure out why, please make sure you reach out to me. But next, we're going to move on to finding the length of one of the legs instead of the hypotenuse. So here we have a triangle where we're looking for the length of leg A, which means they must have provided us with leg B, and of course the hypotenuse C itself. We'll start by writing out Pythagorean's theorem and fill in the values that we're given. Of course, we don't know A, so A squared is going to stay as it is. B appears to be 2.1 centimeters, so we're going to have to square that. And C, the hypotenuse, is 2.9 centimeters, and we'll need to square that. Of course, many of these you won't have memorized, so again, making sure you have some technology like a calculator handy will be helpful. 2.1 squared is 4.41, and 2.9 squared should be 8.41. And so we have a similar scenario here, except this time, of course, since we are looking for a leg, we're left with a value over here on the left, meaning we're going to have to take an extra step or so to solve algebraically. We need to isolate the variable, so we're going to have to go ahead and use our order of operations backwards, or use SADMAP, which means we're going to need to undo this addition first, which of course means use subtraction. That's not a new process for us, and simplify both sides. On the left, of course, since these were inverses, they have canceled out or left us with 0, and we still have a squared. And 8.41 minus 4.41 here on the right leaves us with just 4. And then we see some connections to the last problem. We don't want to solve for a squared. We need to solve for just a single variable, or a. And in order to undo a power, we must use its inverse root. The opposite, of course, of squaring is square rooting. So we'll square root both sides, and that leaves us with a, which means that a must be 2 centimeters long. Just keep in mind again that the hypotenuse must be the longest side. That was 2.9 centimeters. The other leg was 2.1 centimeters, and A turned out to be 2 centimeters, so that is still a true statement. But perhaps if you had finished and said, oh no, maybe A is actually 3 centimeters, that would be a big no-no, and you'd want to double check your work there. And in this first section, that's what you're going to be doing, is really working here with Pythagorean's theorem. I'm going to let you go ahead and try a couple of these on your own before we wrap up this first video. So here are two more where you're looking for a missing leg of the triangle instead of the hypotenuse. Make sure that you write out the theorem first, the a squared plus b squared plus c squared, to help you substitute your values in the right place. Go ahead and pause the video now if you want to try these ones on your own to see how you're doing. And in a few more moments, of course, your solutions will appear. So here you go. For number 3, you should have found that B was 30 yards, and for number 4, A should have been 4 meters. Let me know if you had a lot of trouble there or if you have major confusions. Otherwise, you're ready to move forward. So in conclusion, you now have learned a little bit about the Pythagorean theorem, and you've learned to use the Pythagorean theorem to solve for both a hypotenuse or one of the legs of right triangles. It is important to keep in mind the Pythagorean theorem is only used with right triangles, and you can apply it in some other ways, but right triangles are a necessity in some way, shape, or form. Reach out to me if you guys need extra help. Otherwise, guys, I will see you next time.